We're live. What is this?
Hello, everybody, and welcome to this show and tell. We are doing this as we always do, 7:30 p.m. Eastern Time. We're broadcasting from the Adafruit factory, where we have puppets and 2XLs and payphones and all sorts of exciting things. We have all these wonderful people who have showed up and are going to be showing off the mysteries and magicalnesses of their desks.
That's right.
I can't wait to see them. Call on you in the order in which we have written it down on this piece of paper that I've already started. And then if you're not showing stuff, mute your mic. We have to get out of here at 7:50. Okay. And so take a few minutes. Let's kick it off with
Scott.
Scott.
What you got going on?
Hi. Thought I'd just show you my desk literally and see all the mess that I have on it. For those of you who don't know, I'm Scott. I work for Adafruit doing CircuitPython. And that means I get to hack on microcontroller code all day. So what I wanted to show off was a couple new stuff, things that aren't quite out yet, but give you a behind the scenes look at how things get fixed. So I've been working on the SAMD21 code and specifically the clock. And so I've got this jig here that I made, which is a prototype circuit playground with some wires soldered to it. And this is the SWD breakout here so that I can use the J-Link to talk to it. The J-Link is this green box, this green light here. Super handy. You can get a debugger to everything. And then right now, actually, what I have is a new Metro Express. This is basically the Feather M0 Express and the Metro form factor. And it's hooked up with the SWD line so I can debug it. And then the oscilloscope in the background is the speaker pin output. So what I'm trying to do is get audio playing on the DAC pin. So once that goes in CircuitPython, you'll be able to say like, hey, here's my waveform, play it at this frequency. Give me like an A440 sine wave or all sorts of cool things. Some of my inspiration is there's a really good YouTube video on the Ultimate Game Boy talk, which is all about how the Game Boy worked. And there's a section of it where they talk specifically about the sound. Where you can like load a waveform. Hi, cat. And she decided to get up because I'm talking.
Load a cat.
Yeah, so the talk has all about like you can load a waveform and how you can shift like the frequency or the speed or things like that, and the volume to make all these different sound effects and stuff, which is super cool and kind of what I'm going for with this stuff I'm working on.
All right. I can't wait to hear what you come up with.
I know. I can't wait either, but right now nothing's happening. So that's all I've got to show.
All right.
It's always good to be able to show a work in progress.
I like seeing work in progress.
From the desk of Scott.
Yeah. All right. Maybe
New show coming soon. All right. What's up, JP?
Hey, from the workshop of JP. How y'all doing?
Hey.
So I wanted to show a project I'm working on. I'm working on the guide for this right now and a video for next week. This is a little controller box that I've built, and it's actually a sort of a mashup of the Trellis Mini Unts that the Rees brothers built. I've turned it into a general purpose effects remote control for the RF 900 megahertz range feather boards. So I love the feather boards, and there's a bazillion different feather wings that we can put on them. And I've wanted a way to reliably trigger stuff, especially for theatrical environments where Bluetooth and Wi-Fi usually are problematic. So I've got a little rotary encoder on here so I can select different menu items for different banks of effects. And so the one I've got hooked up that I'll show right now is in this section called lamps. And you can talk to as many feather wirelessly receivers that you want. I've just got one on here, and so I've got essentially an on switch that's going to turn on a spotlight back there and blind you all, and off. So you can, of course, program these things to do effects and use the knob to adjust parameters, kind of open-ended what you do with it. It's all really what you can do in software. But for me, being able to run servos and steppers and AC stuff, in that case, using the power relay feather wing, as well as NeoPixels, which is another use that I have for a specific, there's a circus event coming up that I'm going to do some lighting props for that are also going to use this controller. So that is my little effects controller. I'm super, super psyched about the 900 megahertz radio feather wings.
Nice.
Rad. Thank you. What a neat use, because there's a lot of magicians that are going to be looking to do electronics, or they already do electronics, but they're not easy to use. All right, thank you.
Word.
Next up, Tony.
Hey.
Hey, yeah. So I just want to
Welcome.
mention I did a video last week about what could maybe be the third British invasion potentially. So the microbit is here on the shores of the US, and it's basically the little programmable controller from the BBC from Britain. And it's really cool little thing. So check out the video I did. But I did a video specifically for MicroPython and how to program them with Python. It's pretty straightforward. You go to either a web editor or a desktop editor that they have, and you can start doing cool things. So I had a real fast little demo because they kind of packed in as many features as they could to the MicroPython firmware on the board. And so one cool thing is you can hook up a little speaker. So this is in the shop. It's just a tiny little 8-ohm speaker, and it hooks up to the microbit. So you can see just alligator clips on. This is the microbit behind here. And when I reset the board, it's going to run, and it should generate some speech. I'm going to hold it up near my microphone because it's a little bit quiet. So we'll see what it says.
Hello.
Yeah, it's saying hello world. So basically, you know, it's a simple thing, not super loud, but really cool little demo. Like you literally just hook the speaker up and it's driving it. There's a speech generation library that it's imported and then it made available with Python. So it's 2 lines of Python basically to do that. And so you can make it speak different things. And they've got all kinds of cool stuff. You can do like tone generation, all of the features of the board, like the accelerometer you can use. You can light up the lights on it. So check out that video to see what you can do with the microbit. It's pretty cool with MicroPython specifically. So
Outstanding. Thank you,
Sweet.
Tony.
cool.
All right.
Right.
Chris Young. Hello, Chris.
Hey.
Can you hear me?
Hello.
Yeah.
Yes.
Can you hear me?
Yep.
Uh-huh.
Okay. I gotta go screen share. Hang on. Wake up. Press up tab. Go to sleep. I gotta do iPad, and I'm using it as a communications device. You know, I talked about in my blog about when I was in the hospital, I couldn't communicate while I'm on the ventilator. And now that I'm at home, I'm still using the ventilator at night. So it's a little bit difficult to communicate with my dad. This is a picture of my bedroom. And you can see I have a TV over my bed. I not only watch cable TV on there, I can switch it over and get to my laptop. So if I'm lying on my back, I can see that TV and I can type messages on it and communicate when my dad comes in to help me with something. But I like to roll over on my side and I can't see the TV. So we put a new iPad sitting over there on the side. Here's another view. Well, that way, right on my side, iPad, type messages on it, and my dad can see it. Now the whole thing, it runs by a little control box that has an Arduino micro and an XP radio that runs to a call buzzer in my dad's bedroom, so I can wake him up. And then here's the micro with the XP. It's got a power boost and a backup battery in case the power goes out. We had a power failure one night about a year ago, and I couldn't call my dad, so we have that battery backup. But to operate the iPad, we need some sort of Bluetooth. Oh, here's the buttons that I use to control it. My friend Jonathan says these are a Doctor Strange sling ring. I never thought about that, but it does kind of look like a sling ring.
Yeah.
Anyway, I need to add Bluetooth to the thing. And of course, if I was starting from scratch, I would have started with a Feather BLE, but I didn't want to rebuild the whole board. So I got a BLE SPI friend and wired that into the thing. Then we 3D printed a little stand for the iPad. The legs on the iPad are screwed on there, and you can turn them 90 degrees so it folds up if you need to carry it. And then here's why I printed the stand. I had a little problem with threading. I don't think I've ever had
It looks like an ant farm.
that badly before. But I thought, damn thing looks like a tennis net or something. But anyway, I found out that if I turn the temperature down a little bit, it doesn't get quite as bad. One more thing, I decided I would make some Easter eggs. And so here's a 3D printed Easter egg design that I put together. And one of them is open, and the other one is a solid one. The early attempts were pretty bad. That one got really rapid.
I think that's from Alien. That's an alien egg. It's fine.
I finally shut it off before it fell over. Here's another attempt. Again, lots of threading problems.
I saw that in Cocoon too.
Yeah, but anyway, the final ones turned out pretty good. And as always, you can read about all these projects on my blog at tech.cyborg5.com.
All right.
The eggs are up on Thingiverse, and you can find the link on my blog.
All right.
Outstanding work, Chris.
Yay.
All right, thanks.
All right. Next up, Orlando. Hi, Orlando.
Hello there. Hi. So I'm demoing. I'm not demoing at the moment. I finished my mood badge a couple weeks ago. I told you about the mood badge for kids in hospitals, so they can play their mood and also talk about also play games potentially.
Oh, there you go. Yeah.
So I finished the design for it. Oh, you guys are just staring at yourselves. So I finished the design. So I used an 8x8 LED matrix just because I kind of wanted something a little different. And so it has 3 buttons, left and right in action, for basically simple games and kind of toggling through things. And at the bottom here is the old, at Mega, 328 kind of. It's just really, really reliable. So I just figured, why not? So I had this sent off about 2 weeks ago to Oshpark, and I think I just got notification that it was being shipped. So that's good. So I'll have it to play with over the weekend. So yeah, I'm pretty excited to put that together. Yeah, I actually asked the kids what kind of colored matrix they wanted, and actually they said they wanted a blue one. So I'll be getting the blue one from your store, which I really, really like. I'll probably get red too myself because red's my favorite color. But yeah,
Outstanding.
That's what I'm working on.
Well, keep up the good work and keep showing these projects. Thank you.
I like that they have a favorite color because you can put whatever color, but they're like, if it's going to be my mood, I want it to be like the mood.
Yeah.
Blue's the mood.
We have some black LEDs for me. That's how I roll. All right. Okay. Adam, what's going on this week?
So a lot of progress this week. It started out pretty good. I got my move my fire extinguisher. You'll see why that's there later. I got my electron detector there. This was an interesting thing to mount. I want to share screens because I don't want to take it apart again. But basically, it all came broken. So it uses these. I don't know why they use these cheap plastic pieces, but I got like 3 halves of these things. So I got 2 halves that were close enough together and put enough super glue and baking powder or baking soda in there to kind of fuse it together enough so I can actually get my, it's a photo multiplier tube here. So I had to make sure this thing was really securely mounted. So I was kind of nervous about this, but it's supported with enough zip ties and wood that it should be okay for the time being until I can get a better thing manufactured. So I got my detector mounted. I also got my column liner installed. This piece is about 1.5 feet long of a bunch of different sections of copper. And so you have to clean each one and then very, very carefully thread it up through the center of this thing. It's like playing Operation, except the tip's about 1.5 feet away from you at the very end. So that was a fun challenge to do. And then I also got my electron guns cleaned up. So the way this thing works, it throws electrons down this column. So you got to use one of these electron guns. It's got a tungsten filament in the center that boils the electrons off of. You can see on the right side was the one that came with the thing, and the one on the left side is the one that I cleaned up and spent quite some time working on. But cleaned up, worked nicely. And then I go to power this thing up, and it's exciting. And then it pops, and I find a fuse. So find the fuse. It's in the lower high voltage supply. It is, let's see, stop sharing. It's, let's see, this box down here is the primary high voltage supply, or this is the first part of the power supply, and in the back there's my high voltage tank. So the fuse is out of this thing. Now this is the thing where I found a giant short in a while ago. And I didn't think it did any damage, but apparently it did. Fortunately, I actually had a spare of these. So instead of trying to deal with repairing the one I had, which does not sound fun, I just put a whole new unit in. This microscope's designed so that it's relatively easy to change parts out. So just pulled the old one out, put the new one in, and got the scope online. So I started out with, let's see if I can find the picture. I got a very, very poor image, but that's to be expected with this thing. This is actually an image of a gear on my specimen stage. It's plastic, it doesn't show very well, but it worked. And that's kind of insane that this thing worked. It's the first time in over 17 years I think this thing's been powered up. So, yay.
Cool.
Got closer and closer to better images. And then the popping noises happened again. Everything shut down and went into the emergency shut off. I couldn't figure out what happened. I thought my vacuum pump died because it was making weird noises. It turns out that my microscope's got this really fancy movable stage right here. And this is what allows you to position the sample in the chamber. It's got 5 axes, X, Y, Z, R, and A. And it's all rotary vacuum feed-throughs, which is like the worst thing in the world to do in a vacuum, to make something spin but maintain a perfect seal. And so one of the O-rings in this catastrophically failed and vented my column to atmosphere, damaged my filament. It possibly burnt my diffusion pump oil. I don't know yet, but I carried on. So I've installed my blank. I have a blank, or basically just a steel plate I can put over this thing. Installed that and got the scope back online. Let's share screen.
Oh, I had a question. So what you decided to do is just have a non-spinning one, and it's just going to be stationary as you do your testing.
Yeah, as I do testing, I really do need it though, because you have to position the sample under the electron beam. You can't move the beam around. You can only zoom the beam in. So the solution to this, because I really wanted to keep going once I found out I could actually still operate, was to basically get a pile of aluminum and set my sample on top of that pile and just really, really carefully line it under the electron beam. And that actually worked. I got some relatively impressive images with this thing. So this is a decapped IC chip right here. This actually came in the microscope from Boeing. It's been in there the entire time. But you can see the silicon wafer right there, the bonding wires, and it's actually got a crack through the epoxy. But there's still some issues. I mean, we got a lot of noise around it. I mean, just some really weird problems. This thing's got to go through and have a full calibration done to it. And that brings me to today, right now. About 20 minutes ago, I had the scope, or 30 minutes at this point, I actually had the scope online. I was going to show it off on the show and tell. It was running beautifully.
That's us inside of the machine right now. It's just turtles all the way down.
Oh, whoops. Sorry. There we go.
Yeah. I would have liked a few electrons.
I had an image of the chip up. It was going great. And then popping noises, flickering, and then also smells. This thing has a lot of big electrolytic capacitors in it. One of those blew up. So that I think it's one of the main power capacitors back here in the unit that goes to the high voltage supply. So it made the very unfortunately familiar smell to me immediately before this started. So I kind of rushed to make sure I had this available with me during the show and tell in case any other failures happened.
Yeah,
but it worked, sort of, and then it very quickly ceased to work. But it's been an interesting week.
All right, well, here's what you get this week, because I'm running out of stickers for you. A Cappy the Capacitor pin and a Sparky the Blue Smoke Monster pin.
That is the pin I was least looking forward to.
Well, just put it in a drawer. Okay.
Yeah. Well, it's a good reminder that this thing's going to keep failing. So I got to find an ESR meter now, and I should probably go replace all the capacitors in this thing. Beyond those, I've got some 30 kV capacitors down in there that I'm suspecting are also going to go out at some point. So,
yeah, definitely.
We'll
any electrolytics in there and any tantalums, they're dried up. You gotta,
I found somebody in Poland who successfully ran this thing with all the capacitors in place, and he said, "Sure, go ahead." They were really good capacitors. There's no tantalum capacitors in this thing. But I'm going to have to go through and replace all the electrolytic is what I've decided to do at this point. So I should have done it when I started, but I thought I could get away with it. And
you never know.
Yeah.
It depends on how it was stored. If it's stored in a really dry environment, then yeah, they're going to be dried out. But there's probably not a ton of really big electrolytics. It's mostly ceramics probably, and those are going to be fine.
No, it's a ton of really big electrolytics.
Oh, I'm so sorry.
They're like, oh.
Yeah.
They're cool.
I think it's the same size as
they're scary and they're cool, but that's what it is. So.
All right. Well, you know what? We've all been there.
Yeah. And
part of the process.
For quite some time. So.
Do they look like Cappy? Are they about this size? I mean, is it like...
that's actually a relatively good approximation.
Yeah. All right. All right. Well, you get one of these pins. Hey, watch out. Okay.
Yeah.
At least you know what to look for.
No, I mean, no better way to learn than just to mess around with something like this. So.
Hey, you get a free pin out of it.
And caps are pretty cheap. You can buy those capacitors are only like $1 or $2 off DigiKey. You'll be ready to go in no time.
Yeah, it's just so the way this thing's built is it's board next to board with another board mounted at 90 degrees to that, and it's all 3D and insane with wires just going everywhere. So the challenge is going to be access to the back of the board to desolder. But other than that, it'll be pretty interesting. So
Ain't no thing.
Ain't no thing.
We're here every week. You
We
have a lot
knew
of
you were
time.
going to do it. It's all good.
All right, Adam.
more time, right? That's
Thank you so much, and keep up the good work.
It's been waiting 22 years. This
Yeah.
is nothing.
yeah.
All right. Thank you, Tony. Thank you, Scott. Thank you, Orlando. Thank you, JP. Thank you, Chris. And thank you, Adam. We're here every single week, 7:30 p.m. Eastern Time. Show and tell every Wednesday. Hey, Data. We're going to do Ask an Engineer next.
That's right.
All right. Thank you, everybody.
Thanks, everybody.
Half an hour of live electronic sharing online. The biggest digital show and tell on earth, I think.
Everything from little electrons to big iPads
Yeah. To magic.
to magic
Yeah. All right.
to microbits.
Bye-bye.
Okay, bye, everybody.